Hi, I welcome you all for the lecture series GoF Design Pattern from OYAD. Myself, Shankar, Assistant Professor, Department of Computer Science and Engineering. Let us see what is GoF Design Pattern. GoF in the sense gang of four. Gang of four design patterns. Actually, in 1994, four authors, Eric Gaumer, Richard Hahn, Ralph Johnson, and John Wilsets. They have published a book titled called Design Patterns, Elements of Reusable Object-Oriented Software. These authors are collectively known as Gang of Four. It is actually general responsibility assignment software patterns. Already we have discussed that GRASP. So GRASP is a set of guidelines for assigning a responsibility to the class and objects in the object-oriented design. So we are talking about design patterns. What is pattern? Pattern is a named description of a problem and solution that can be applied to new contexts. Ideally, a pattern advises us on how to apply its solution in varying circumstances. There are three types of patterns are there. One is creational pattern, and next one is structural pattern, and another one is behavioral pattern. Each type of patterns have many different types of varieties of under that patterns. For example, they have listed only few because I have noted as per our syllabus. For creational, I have taken only factory method. For structural, I have taken only two. One is bridge pattern and another is adapter pattern. From behavior, I have taken only two, strategy and observer pattern. Right, so let us see what are the patterns may have under creational, structural, and behavioral. Under creational, the design patterns are abstract factory, builder pattern, factory method, prototype, and single tone pattern. So this all together comes under creational pattern. The scope of these patterns also given. All the above creational patterns are the scope of objects only. Next, we have structural pattern. Under the structural pattern, we have adapter pattern, bridge pattern, composite pattern, decorator pattern, facet pattern, flyweight, and proxy. Except adapter remaining all with the scope of objects. The adapter only to the scope of class. So as of our syllabus, we have only two patterns under structural, that is adapter, and another one is bridge. And next one is behavioral. Sorry, here L is missing. Behavioral pattern. Under behavioral pattern, the design patterns are chain of responsibility, command pattern, interpreter, iterator, mediator, memento, observer, state, and strategy pattern. All belongs to the scope of objects except interpreter because interpreter is responsible for the scope of class. So as of our syllabus, we have only observer and strategy under behavioral. Let us see one by one about the patterns. So under creational pattern, initially we have factory method. Factory method. The factory pattern is one of the most used design in the design pattern in the Java. In factory pattern, we create objects without exposing the creation logic to the client and refer to newly created object using common interface. The problem with this factory pattern is we don't know who's the responsible for creating objects that are required for the complex creation logic. The solution for the problem is create a pure fabrication object called factory that handle the creation. To implement this factory pattern, they have given some steps. So initially, you create an interface. Next, create the concrete classes to implement the same interface. After that, you create a factory to generate object of that concrete class based on given information. So as of this example, the file name is shape factory.java. Step 4 is use the factory to get objects of concrete class by passing information such as type, finally, we can get verify the output. So one example is given for the implementation. So in this case, create a shape as an interface and create concrete classes to implement the shape interfaces. Factory pattern demo is the factory class. This class will use the shape factory to get the shape of the object, and it will pass the information about the circle class, rectangle class, and square classes to shape factory to get the type of the object it needs. And next is structural pattern. So under creational, we have only one as of our syllabus, that is factory pattern. That's why we have discussed only factory pattern. And next, bridge pattern. Bridge pattern is actually comes under structural pattern, right? So the bridge pattern is used when we need to decouple an abstraction from its implementation so that the two can vary independently. This types of design pattern comes under structural pattern, as this pattern decouples implementation class and abstract class by providing a bridge structure between them. Next, let us see the implementation phase. The first step is to create bridge implementer interface. Next, create concrete bridge implementer classes implementing draw API interface. The draw API is the name of the interface, right? So don't get confusion. This is the interface name with the example. Let us see the example in the next slide. Create an abstract class shape with the help of draw API interface. Next, create concrete class implementing the shape interface. This all are having the examples, right? So here we are discussing only steps. Don't get confused. And next, use the shape and draw API classes to draw different colored circles. Finally, you can get verified. So that diagram is given here. Once again, I'm repeating here. Initially, what we have to do? Initially, we have to create bridge implementer interface. Bridge implementer interface is here. You just listen the cursor here. This is bridge implementer interfaces, right? Here. Next, you have to create bridge implementer classes implementing the draw API interface. So this is draw API interface. We have to make a bridge between this class implementer with the API interface draw API. The next step, you have to create an abstract class called shape using draw API interface. This is shape, right? We are using draw API interface. With the help of this, we are creating abstract class called shape. And next, we have to create a concrete class implementing the shape interface. That's why we are extending the circle here, right? And next, we have to use the shape and draw API to draw the different colored circles. That is actually here, right? Yes. And next, under structural pattern, we have another pattern called adapter pattern. This is the another pattern under structural. Adapter pattern works as a bridge between two incompatible interface. This type of design patterns comes under structural pattern. This pattern combines the capability of two independent interfaces. Problem with the adapter pattern is how to resolve incompatible interface, how to provide a stable interface to the intermediate having different interfaces. Solution for that problem is to convert the original interface of the component into another interface through intermediate adapter object. The example is given for adapter pattern. In this adapter pattern, we have a media player interface and a concrete class audio player implementing the media player interface. Audio player can play MP3 format audio files by default. We are having another interface called advanced media player and concrete classes implementing the advanced media player interface. These classes can play VLC and MP4 file formats. We want to make audio player to play other formats. To attain this, we have created an adapter class, media adapter, which implements the media player interface and use advanced media player objects to play the required format adapter pattern demo. Our demo class will use audio player class to play various formats. Next type of pattern is behavioral pattern. Under behavioral pattern, we will discuss first strategy pattern. Let us see what is strategy pattern. The strategy pattern is a class behavior or its algorithm can be changed at runtime. This types of design pattern comes under behavioral pattern. Implementation for the strategy pattern is create a strategy interface defining an action and concrete strategy classes implementing the strategy interface. Context is a class which uses a strategy. Strategy pattern demo will use context and strategy object to demonstrate change in context behavior on strategy it deploys or use. For implementation, we have the following steps. The first steps, we have to create an interface. Next, we have to create a concrete classes to implement the same interface. And next, we have to create context class. Next step, we have to use the context to see change in behavior when it changes in strategy. Finally, we will verify the output. So let us see the example. So in this, we have created a strategy interface. With this strategy interface, we have implemented three classes called operation add, operation subtract, and operation multiply. For this, we have created a strategy pattern demo as main method. And it's for this, we have created a context class. In this context class, we have created a strategy. For under that, we have used the execute strategy. In this case, we are giving the option with the help of integer. If it is 1, it may goes to add. If it is 2, it may goes to subtract. It is 3, it may goes to multiply, and so on. And next one, behavioral pattern. For behavioral pattern, it's the next example is observer pattern. So let us see observer pattern under behavioral pattern. The observer pattern is a design pattern that defines a link between objects so that when one object state changes, all dependent objects are updated automatically. The problem with observer pattern is what could be done when some object generates an event and in response to that event, different kinds of subscriber object changes the state. The solution for that is define the subscriber interface. The publisher dynamically registers the corresponding subscribers and notifies them when some events occurs. For example, on a scenario is given for an example, which is consider that a school sends a notice to the students through SMS or by mail. The notification system works as soon as some events occurs. For example, if the notice like due to heavy rainfall, the school will remain closed today, can be sent to the students either as a SMS or as an email when heavy rainfall occurs. Here, the school notification system object will act as publisher and student object will be a subscriber. So this is, let us consider this is an assignment for taking, drawing the diagram for the observer pattern. Thank you. Thank you all for watching this lecture series. Thank you all.